Hi guys, so today we're going to talk about rates of change and tangent lines. And this is going to relate very closely to the conversation we had on one of the first days of school where I sent you in the hallway to do a walking experiment. And then we talked a little bit about some of the vocabulary we were going to be encountering this year. So one of the things we talked about was point-slope form of the equation of a line. And we said that in this class, you're always going to write your equations in point-slope form, which looks like this. Y minus y1 equals m parentheses x minus x1. Now within this equation, obviously there are a lot of missing pieces of information that we're going to fill in. The first one is that m is always the slope, and x1 comma y1 is the point that the graph goes through. What this means is that for every single time a problem asks you to write the equation of a line, and there are going to be three types of lines we're going to write, but every single time you're going to start by identifying the slope of that line and the point that it goes through, because once you have those two pieces of information, you're set up to write the equation. So let's start by reviewing secant line. A secant line is a line that cuts through a graph to connect 2 points. When we need the slope of a secant line, we use something called the average rate of change, which is another term for regular old slope. So the formula for average rate of change would be y2 minus y1 over x2 minus x1. Now, whenever you're writing the equations of these lines, you're always going to have 2 points. So that's why we use this slope formula, because we need 2 points to use that formula, and we're going to have 2 points. So let's take a look at an example. It says write the equation for the secant line to this curve over this interval. Well, in order to do that, I know I need 2 points. So I'm going to calculate point number 1 and point number 2. Point number 1 is going to be calculated by taking the first x value from my interval and plugging it into my function. And point number 2 is going to be calculated by taking the second x value from my interval and plugging it into my function to calculate the y's. So when I do that, f of 1, my first x value, would be 1 cubed minus 1. And 1 cubed minus 1 gives us 0. So our first y value would be 0. To calculate my second y value, I would plug the number 3 into my function, and that would give me 3 cubed minus 3, which would be 27 minus 3, which is 24. So 24 would be my second y value. Now to calculate my slope, I would just do 24 minus 0 divided by 3 minus 1, which is 24 divided by 2, which is 12. So now I've got the information I need. I've got a point and I've got a slope. And in this problem, I've actually got extra information. I actually have 2 different ordered pairs. And I could use either one of those ordered pairs to write the equation of the secant line. I'm going to choose to use the first equation, and then I'll show you how the equation that you write would change if you used the second ordered pair. So I'm going to have y minus, and the y value here is 0, equals m, which is 12, parentheses x minus the first x is 1. Or, if you wanted to use the second point, you would have y minus 24 equals 12 parentheses x minus 3, and either one of those answers would be acceptable. That's totally fine. Now let's talk about the second type of line that we're going to be asked to analyze in this class. So the second type of line is a tangent line. And a tangent line is a line that brushes against the graph to touch only one point. So the big difference here is that instead of having 2 points, we're going to have 1 point. To find the slope of the tangent line, you use something called the instantaneous rate of change. And what I'm going to show you now is where the formula to calculate the instantaneous rate of change comes from. So unlike this example where because we had learned a slope formula for 2 points in Algebra 1, we could just use that formula, here we're going to have to develop a formula. And I'm going to kind of walk you through the development process because I find that that makes it easier to remember it because you actually hopefully understand where it came from. So the first thing is, let's start with what we know. We know that if we have 2 points, we can just do y2 minus y1 over x2 minus x1. So let's maybe build our formula from there. What we're going to do is choose 2 points on this graph, but we're not going to call them x2 and x1. Let's call this point x. And let's call this point x plus h. Think about it like this. If x was 2 and this was 5, then 5 could just be thought about as 2 plus 3. So 3 would be your h. It's how much you added to go to the right to get to this next point. So h is the gap between these 2 points, which in this problem, if this was a 2 and this was a 5, the gap would be 3. Now, if we call this first x coordinate x, then its corresponding y coordinate would be f of x. It's the y value that corresponds to that x value. And the second x value is x plus h. So that y value, which corresponds to that x, would be f of x plus h. If we set up our slope formula, this same formula we just did here, but we use our new x and x plus h instead of x1 and x2, and we use our new y1 and y2 instead of y1 and y2. So this would be like y1, this would be like y2, this would be like x1, this would be like x2. If we plug those things in instead, here's what our formula becomes. Instead of y2, we're going to write f of x plus h. Minus, and instead of y1, we're going to write f of x. All over, instead of x2, we're going to write x plus h. And instead of x1, we're going to write just x. Now, if we take a look at this formula, there's something that we can simplify. So in the denominator, we have x minus another x. So those things would cancel. So our new, more simplified formula would be f of x plus h minus f of x all over h. Now you might recognize this formula from pre-calculus. We called it the difference quotient, and this is where the difference quotient comes from. It's actually the same thing as doing y2 minus y1 and x2 minus x1 if you just happened to name your points the way we named them just now. Now how is this helpful? Well, remember how we said h was the distance between these 2 points? If we want our graph, our line, to only touch one of those points, then what we need to do is slide these points close together. We're going to slide them and sort of pinch them together. In other words, we want the distance between them to be 0. So that the points are basically on top of each other. Which means we're going to add an extra part to this formula that we didn't have in pre-calculus. And we're going to say, use this slope formula, but take the limit as h approaches 0. Now, adding this in slides the points closer together until they're basically on top of each other. And this part right here calculates the slope. So by calculating the slope for 2 points that are on top of each other, what we end up getting is the slope that only brushes 1 point. Now this is where the formula comes from, but at the end of the day, what you really need to know is this formula. You're going to need to have it memorized, and so one of the ways to ensure that that happens is that you write it at the beginning of every problem. So in the next example, where we're going to actually find one of these slopes and write the equation of a tangent line, we're going to go ahead and write that formula as our first step. So let's try that. In problem number 2, it says find the slope of the parabola y equals x squared at the point 2, 4. Now, point 2, 4 is 1 point. It doesn't say on an interval between 2 and 4. So because it's giving us 1 point, and because it's saying write the equation of the tangent line, which we know touches 1 point, because of those two pieces of information, we know that we're going to need to use this formula we just developed to get the slope. So in order to write the equation of the tangent line, we need a point and we need a slope to write that equation. The point that we're working with was given to us in the directions. We are going to calculate the slope and then put those things together to write the equation of the tangent line. So I'm going to use this space to calculate that slope. The first thing I'm going to do is write down my limit. I know that my slope can be calculated by taking the limit as h approaches 0 of f of x plus h minus f of x all over h. So let's talk about how to actually use this formula. The first thing I'm going to do is use the formula to plug some stuff into my original equation. The first thing that I'm going to plug in is x plus h. So what that means is take x plus h and replace x with x plus h. So I would have x plus h squared, because this says take whatever you're plugging in and square it, and what I'm plugging in now is x plus h. Next, I'm going to plug in x. So the formula has a minus in it, and next I'm going to take x and plug it in to this original equation. So I'm going to have x squared all over h. Now I'm going to try to simplify. So in order to simplify this, I'm going to write out x plus h twice, because x plus h squared really means x plus h times x plus h. Now x squared doesn't really simplify, so I'm just going to copy it down, and I'm going to put the h in the bottom. Now I'm going to multiply x plus h times x plus h, and to do that I need to distribute the x, so I'm going to have the limit as h approaches 0, which don't forget to write that every single time. X times x is x squared. X times h is plus xh. H times x is plus hx. And h times h is plus h squared. Then I'm just going to copy down the minus x squared and the divide by h. Now once I do that, there is some simplifying I can do. So I'm noticing that on the numerator I have x squared, and then over at the end I have a minus x squared, which means they cancel. So my simplified limit would be the limit as h approaches 0. Again, I'm just going to simplify a little bit more. X plus h and xh and hx are really the same thing. So we can just write that as 2xh plus the h squared all over h. Now as soon as you get to here, you know you're almost done, because at this point we can actually cancel 1h from every term. So my new limit will be the limit as h approaches 0 of, and I'm going to have 2x plus h. As soon as the h cancels, you know you did it right. At the end of the problem, all you're going to do is take the h is 0 and plug it in for h, because that's what a limit says to do. If you can plug it in, plug it in. I forgot to mention that at the beginning we could not plug it in, because if we plugged in 0, there would be a 0 in the denominator. But now that the denominator canceled, we can plug it in. So our limit would just be 2x plus 0, which is just 2x. When you get to your final answer, you should not have any h's, you should not have any denominators, you should not have any limits, you should just get a formula. And this is a special formula. This formula allows us to calculate the slope at any value of x that we want. Now, in this problem, the value of x that we want is 2. So to calculate the slope, I would just do 2x, which would be 2 times the 2 from the ordered pair, which would be 4, which means that my tangent line equation would be y minus the y value, which is 4, then m, which is 4, parentheses x minus 2, the x value. Okay, so that's how you do a tangent line, and we have one more line we need to talk about. So the normal line is perpendicular to the tangent line. So the slope of a normal line is the opposite reciprocal of the slope of the tangent line. Now we know, if you want to review, a secant line would cut through the graph and touch 2 points. We did this on like one of the first days, but just as a review. A tangent line would brush the graph, just sort of touch in 1 point. And a normal line would be perpendicular to the tangent line. So it would look like this, where there's a right angle there. So let's find the equation of a normal line. We've done one secant line, we've done one tangent line, let's do a normal line. Problem number 3 says find the slope of this parabola at this point, and then write an equation for the line that is normal to the parabola at that point. You'll notice that I gave you the same equation and the same point as problem number 2, which we just finished. So the reason I did that is I didn't want to go through this whole limit process again. We're going to practice that tomorrow in class. But I wanted to just be able to use the result from problem 2 to do this problem. So just like in problem 2, they give us the point in the directions. Now in problem 2, we calculated our slope to be 4. So the slope of my normal line would be -1/4. Opposite reciprocal. So flip it over and make it negative. Which means my normal line equation would be y minus 4 equals -1/4 times x minus 2. All right, that is it for these 3 types of lines. I will see you guys tomorrow for some additional practice, especially with this whole getting slopes of tangent line things, which is definitely the more complicated part. And I thank you so much for watching the video. I will see you then.